In previous videos, we have looked at control flow. That means which steps are to be executed when. We've also looked at resources. Who does what? Today, we're going to look at data. In this video, I'm going to show you how to model anything that people need in order to perform a business process. So a business process is actually all about data. We need people to do it. Yes, we need to know which thing they need to do, but they need to work on something, right? You cannot just start a business process and then work on nothing, have no output. There are very few business processes that work that way. So BPMN contains a large part on the data perspective. And they come in three types. We have already seen hidden data. Hidden data is data that is not explicitly modeled by means of modeling notation, but rather in the text and in the words, kind of as a communication between people. So here in this small example, we see that assess the form would probably set a Boolean flag whether the form is approved or rejected, and then the gateway, the XOR gateway after that, use that data to establish true conditions which of the paths to follow. This is hidden data because it is not explicitly modeled. There is nowhere to be seen here that says that there is such a thing as a decision on whether the form is accepted or not. It's not modeled, so it's hidden. Another type of data comes in two flavors. The data object. And a data object models any type of data that is relevant to the current scope of the current process instance. So this is data that belongs to the current thing that we are processing and not to anything else. So it doesn't get kept afterwards. It doesn't interact with anything. It's just local, so very local. So process instance only. If you have multiple data objects kind of representing the same thing, so let's say data object is exam paper and you have a whole stack of exam papers, then you can use so-called data collection. And we use this, the marker with the three vertical lines, also used for multi-instance. And this is called a data collection. So it's exactly the same thing, but then more of it. So a list or set or other collection of data objects. Data collection as a whole is also only available for the current process instance. So when the process instance ends, this data is not relevant anymore. Finally, we have a data store. So a data store remembers data beyond the current process instance. So let's say that we want to archive something, or we are looking at a warehouse and checking stock. That would be all the data store, because it does not just relevant to the current process instance, but also further beyond. Now we know about the scope of the data object, data collection, and the data store. But what is now the scope of the hidden data? Well, because it's not modeled explicitly and the BPMN standard really doesn't say much about it, we keep this for small data. So let's say it is local to the process instances, but just to communicate between one task and one gateway, something along those lines. If we look a bit more into hidden data, why is that? Why do we need that? Even though the BPMN standard is XML based. So this hidden data can be specified in a BPMN model, but only in the XML variant of the BPMN model. Now, XML is a communication tool between computers. It's not very suitable for people to read. So there is no way to put this small data or this hidden data explicitly in a process model except in XML, but you cannot see it if you visualize the model like we do here. So we need hidden data in order to kind of make make it work. We cannot put data objects everywhere, and we just need hidden data. And this limitation, there is actually more to it from the side of BPMN. BPMN does not have a data language specified. So any vendor can come up with a way to write down Boolean expressions and data types and kind of plug it into BPMN. That means it's very flexible, but it also means that any vendor can come up with their own way. So if you specify these Boolean expressions and data types, it will be in the XML, and you need to make sure that the tool that you're using to read that XML actually can handle that. It's not part of the BPMN standard. They only provide a suggestion. For data objects and collections, how can we use them? Or what do they add? What do they mean from the model side of things? If you have a dotted line from a data object to a task, that dotted line is called an association. What it means is that in this case, the task can only execute when the data object is there. Furthermore, the data object can be used by the task, so as an input. The opposite, we simply reverse the association. This small model tells us that task either updates or creates a data object. So as a result of the execution of task, data object is updated or created. For a data store, we also have input and output, but as a data store extends the scope beyond the current process instance, this is always there. Data store is always there. So we get information from a data store that again with an association, or we write data to a data store again with an association. And if you want to use a single dotted line with two arrowheads, that's also fine. Note that I can duplicate data objects, and that doesn't change the meaning of the model at all. So these symbols that I use, so the little paper with the folded corner and the database icon, they refer to data objects. They are not the data objects. So if this would be one model, then there would be only one data object called data object. It's the same thing, we're just referring to that. And we will see in an example shortly why that is. If you have only one data object, because a data object might traverse a lot of parts of the process. So you might create it in the beginning and then update it and use it at the end. So you might end up with a process with the associations going everywhere. That's a bit cluttery, so you can simply duplicate them to avoid that. You don't have to, but you can. Do we model all data objects? And what exactly do we model using a data object? I already mentioned that we have constructs for the control flow and for the resource perspective of BPMN. Basically, everything else is modeled as a data object. So a data object can be things that are input and output to tasks. That means it can be electronic or it can be physical. So it can be an email, that is a data object. It can be a database record, that's a data object. It can be a form submitted through a website. So very electronic, just data, any type of data, images or videos, whatever. Everything there is a data object. It can also be physical. So, for instance, if I'm producing a car, then that car is a data object. And the steering wheel of the car is a data object. And when they are merged, then I still have a car, it's a data object. So keep in mind, data objects are anything that people or machines work with that they need in order to execute a task. And what they produce by doing a task. So, do we model all data objects? Well, as usual in process modeling, the answer is it depends. If there is a large model with lots of detail that needs to be implemented in an information system, then yes, we need to model all data objects, because in the end we need that system to say to a particular user, here is the form that you need as input for this task, and then you can upload your answer here, or you make a web form, that's the output, it's the data object. So there you need a very detailed specification of anything related to data objects that goes on in a process. And we need for that much detail, we need data types. That's one end of the spectrum. So implementation models, very low level, lots of detail. To the high level, if you have an overview of the whole process of a student journey going through university, then it doesn't make much sense to include all these data objects, right? So if you're looking at that level, so one activity would be registration, another would be doing exams, and another one would be getting your diploma in the end. If I'm thinking at that level about a business process, it makes absolutely no sense to put data objects in there. Who cares about a grade, about a single grade? I can connect that to the exam with an association, but I don't want to know that at this point in time, right? So, or a detailed a form you submit in order to get an extension on a homework assignment, or a process that you go through, a receipt of a doctor's visit, a medical certificate. At that level, I don't want to know that. So these are two extremes. So on one hand, like the very detailed implementation, and on the other hand, the high-level overview. And it depends on your modeling purpose and where you are on that spectrum, whether to include data objects and which data objects to include. So that was the long answer. The short answer is no. Let's look at an example where we use data. This is a small business process of a seller who receives an order and then checks the stock availability and so on. Let's walk through it. So in the first step, the start event is a message event. This will contain an order. So here we're getting an order from a customer, and that is of course a message, because we communicate between parties with messages. We have modeled that using this purchase order object. This is a data object, and we see that the association runs from the start event to this purchase order. So from this start event we get a purchase order. That's our data object, and now we know that. Notice that purchase order is a data object and not a data store. Why is that? Because it's local to this particular process. This is the order we're working on. So it doesn't make sense to send that off to a warehouse for archiving, but we keep it local. Then, the check stock availability task that needs two things. It needs the purchase order, because somebody needs to, or can be done by a system, whatever. You need to take the items from the purchase order and check in the warehouse database if the items are still there. So you see that we have an association from purchase order to check stock availability. That means that we have as input the purchase order into check stock availability. Then we need information from the warehouse database. So that is another association. So we check for each item whether it's available, and we write that and that's this association, into the purchase order again. That's check stock availability. Then we use this hidden data. So in the next step, in the gateway, the XOR split gateway, we need whether the items are available or not. So for that, we use the conditions, and these kind of implicitly refer to the outcome of check stock availability. So this is hidden data. If all the items are there, then we can ship the order, and then you see for ship order we need the purchase order. Of course, we need to know what to ship, and we need to read from the warehouse database and update that again. So now we take items from the warehouse database, so we have to update that. So this association from warehouse database goes in both directions. If we do not have all the items in stock, then we send an apology, and again in that apology it would be good to mention the products that were ordered, or at least we need to know who ordered it. So we need the information from the purchase order denoted by this association. Finally, there is an archive step, and an archive step is a bit of a technical thing from older times. So what the archive step does is it takes the purchase order. Well, we've modeled that one, and it like in old times, you know, you had stacks of papers in big file cabinets, and then archiving would mean taking it from kind of the stack of current purchase orders and moving it to the archive, which is a different file or different room or different building. So that was the archive step. You would say nowadays, do we still need to do that? And well, of course, yeah, have to. You can of course avoid it, but still it is a good idea to make a distinction in running cases and non-running cases. So in the running cases, people are interacting with the data object. So as long as we are on this side of the process, on the left side of the process, we are still working on this purchase order. That means that everything, if you think nowadays, everything needs to be instant. You need to be able to quickly get there, interact with it, and update whether it's available, and so on and so on. You don't want that on slow storage. On the other hand, on the right side, on the archive, that doesn't matter anymore. Once we're done with it, we can kind of put it into a second tier of storage in a data warehouse. We don't need to be able to access that every day and that quickly. And that also has all kinds of implications for backups and so on. So yes, there are still technical reasons why you would want to have a distinction between data objects and data stores. So here what we modeled is in the archive step, we take the purchase order and we store it into an orders database or a data warehouse where it can still be retrieved. It's not gone, but we don't need it anymore. This wraps up the data perspective. I've shown you how to use the data perspective, the associations, the data objects, the data collections, and the data stores. And I've shown you why you would want to include the data perspective and how to do that.